Hi everyone, my name is Sai. I'm a senior data scientist in Klarna. Today, I'm about to present ML Legobricks. This is a machine learning operations project that I made for prevention team within Klarna. Eventually, we want to kind of like advertise it globally within Klarna, so everybody, like at least every data scientist and every analyst can use that to build a model. Then let's start. Who am I? Well, this is not very important. Like I have introduced myself already, but if you want to find me later, here's my LinkedIn profile. What is Klarna? For people who haven't heard about Klarna before, or who does not know much about Klarna before, Klarna is a payment method provider. And by the way, you are free to interact me anytime or raise your hand if you have any question. I would prefer like interactive kind of like activities rather than leaving Q&A at the end. So you can raise a hand anytime if I speak too fast or anything wrong. What is Klarna? Klarna is a payment method provider. Basically, if you're shopping online, you usually have see some options, like you can pay by PayPal, you can use your credit card, and Klarna provides pay later, slice it, and sometimes using Klarna card. So it basically have two groups of users. First one is merchants. So we're helping merchants to kind of like secure their items and their money. So we take all the fraud and risk, we take all the fraud and risk from the customer side. So the merchants won't need to care about that. They will always get paid by their order. And we also take care from the customer perspective. We kind of like allow them to pay whenever they prefer to. So let's check some basic numbers about Klarna. In the recent 5 years, Klarna has been kind of like gradually grow up as a biggest unicorn in Europe. We have markets globally around 17 countries. We have 20K more merchants, 3,500 more employees, and we have 1 million transactions per day, more than that. And most importantly, we have like $10 billion has been evaluated lately, probably even more. Here are three our signature products: pay now, pay later, slice it. The basic concept is we offer you very quick and smooth checkout. You only need to provide a minimal personal information. And running behind, we are taking all the risk for you and for the merchants. How can we do that? That comes to our next topic, what is fraud? Like not just in Klarna, like globally, we have three different kind of like categories of fraud. We have ID theft, which means someone took your identity, ruining your life, who's claiming himself or herself as you. And we also have some money mirrors. We also have people who's like intentionally using wrong information to taking advantage of the merchants. There are like kind of like small other concepts of groups, but in general, we have those three main category of groups. As I said before, Klarna provides three main payment methods, and all of them are advertising by smooth payment checkout, which means all the risk of including all of these three categories fraudulence will be taken care of by us. Maybe it's too fast. Let's go back to say the category of fraudulence again, because that is kind of like strongly related to the model. So we have ID thefts, credit card fraud, abusive behavior, which means you are intentionally want to take advantage of merchants by lying. And you have borrower ID, and sometimes we do have some loopholes. So in fraud prevention team, which is my current team, one of our main mission is to fight against fraud. And how are we going to do that? So here is a quick example of Klarna checkout. This is a typical phone iframe. If you have trouble to, I can't make that bigger. But I can explain that. So for example, here is a very common payment method. And you only need to provide your first name, last name, shipping, billing address, and certain very, very limited information. And at the time you click this button, we are running an advanced model behind you and checking if you were a fraud or not. So basically, this sophisticated decision engine is made of machine learning models plus some binary rules. And my job here is to create machine learning models to increase both precision and recall, like in purpose of reducing fraud rate, as well as make sure my customers have smooth payment experience. Any questions so far? Great. So now let's talk about I'm gonna smoothly ease you into today's main character, ML Legobricks. But as I mentioned before, my main job here is to building machine learning models. Then the question naturally raised is, what does data scientists do? And how do we build machine learning models, specifically in the prevent of fraudulence? And of course, there are other questions come along, like what are actually machine learning models and how do we deploy that? How do we evaluate? How do we monitor models? But here in this specific topic, I'm only going to go through the first question and the third question. So what does data scientists do? And you may think this question is a little bit offensive because I'm sure you know what does data science do because you're the audience of PyData. However, this is just to help you better understand what does ML Legobricks do for the later slides. So please bear with me. And the third question, how do we build the machine learning models? That is more than kind of like a summarized question. It's supposed to just help you to quickly refresh what are basic prerequisites we need to build a machine learning model. That would also be a building block for ML Legobricks in the further slides. Here's the answer. Well, as data scientists, eventually we are a group of people who's applying operations on data side. It can be any operation, but eventually we are applying a sequence of operations on data sides. And by sequence, I mean, of course you have different options, but you will always have to start with raw data, then cleaning up, then feature selection, then pre-processing. And further, you can train, you can tune, you can calibrate, eventually get out a model, monitor, reporting, further deployment. So this is pretty much the sequence we're always following. And in each small sequence, we always have very similar other operations applying on this part of sequence. Do we have any different opinion here? I guess this is a no. Then let's quickly recap previously on model building tools. The previously is only limited in the scope of Klarna. I don't speak for other companies and other projects. So we usually start with Jupyter Notebook for basic EDA. Then we move things gradually to a real Python project. Use Python, VS Code, whatever editor you want to use. That brings some dark sides. Oops. Dark side. Repetitive code, right? Every time you start building a model, you will have to spin off a notebook instance. And you pretty much check same things all the time, even though for different data set, even though for different model. You always check the missing rate of the feature. You always counting something. You always check the Pearson correlation, wording, your target and features, crime and value, basic statistic overview. You're doing this stuff like, repeatedly, like day by day, every time, every project, you start doing this kind of thing. And eventually you have like thousands of lines of code piled up in different notebooks. That brings to the second dark side, which is hard to debug. If you're doing all of this experimenting on notebook is very famous of presenting pictures and very convenient to use, but it has a limitation on cache memory, and it's very hard to debug. You can't go to your code like very easily with a linking, and there's no test function. This is basically just a playground. And even though after you move everything from Jupyter to a real Python project, you're still kind of like moving around with copy and pasting. There are lots of manual work which you can avoid of in the first place. That is a previous model building tools, which happened in Klarna. Now let's bring our main character to the stage. What is ML Legobricks? ML Legobricks comprises 3 components. And by the way, I cannot see any other audience except for myself. So if anyone has a question, feel free to ask. ML Legobricks comprises 3 components: a code sharing library, a Sagemaker folder structure, and a cookie cutter template. I will dive into that in the next slides. What are they? Okay. The first one, the code sharing library, we pretty much built a like a helper library, like scikit-learn within Klarna on Bitbucket, which is nothing more than a Git code management. It's just like we try to make our code clean, tidy, and appropriate. So every single function will have a test function, like everything has been done properly. And this code sharing library is fundamentally important to ML Legobricks. But I'm pretty sure every data scientist, like experienced data scientist, somehow, like always, will have like certain maybe 20 to 50,000 lines of code piled up in their laptop. Eventually, they can make their own code sharing library by organize them. But here we are talking about a centralized code sharing library, which has been created within our team. That library will be very important for ML Legobricks, and I will explain furthermore in other slides. Second one is Amazon Sagemaker. Sagemaker is a powerful, strong tool. It has so many layers, so many perspectives. In ML Legobricks, we are only using training, pre-processing, and tuning. For audience who are not super familiar with Sagemaker, it's fun. I can explain into details later. So far, you only need to know this is a AWS machine learning service. And we're connecting our Bitbucket to Sagemaker by using Docker image and ECR. Sorry. The third component is cookiecutter. This one eventually is only a tool to help you create a project. And I have a small demo here just to quickly show you how it's done. So here we are actually git clone this cookiecutter data science project. And in the beginning of this project, with the template you have created, it will ask you some questions regarding to folder's name, project's name, and anything you can imagine. For example, you're confidential to AWS, what is your target value? If you want to add something like environment variables, everything can be created as a template before you create this project. And by using cookiecutter, you can create a project template with certain predefined variables. This one is very important because later you will see cookiecutter works like a bridge to glue SageMaker and Bitbucket all together, such that we can create a template of model by one click away. If we don't have any question regarding to cookiecutter, I will move to next slides, but we can always come back to see this demo again. So cookiecutter comprises 3 components. Then what can we benefit comparing with the dark side with previous model building tools? We have no more repetitive code because everything has been moved to the centralized code sharing library. And we will have standardized model building cycle because as I said, data scientists are only applying sequence of operations again on the data side. This building cycle will be standardized by calling ML Legobricks. And certainly the crowdsourcing, because ML Legobricks eventually is in very low level establishment. There is nothing complicated, nothing fancy. Everything has been written by class and functions with Python. Anyone can contribute in this library if they are willing to. And firstly, by using ML Legobricks, like gluing 3 components together, we allow you to build a model by one click away. And lastly, it's very flexible. You can pretty much cook your own model. And maybe the word cook sounds a little bit weird, but I will explain later in the next slides. But important thing is, this is very flexible. You can plug in and out different components, different bricks to have different pipelines. Eventually you will have different model. And even parallelly, you have different model running at the same time and give you different reports. And all of this can be done by one click. Now you may ask me how. And behind every great product, there's a story. I saw Steve Jobs said that, then Google, it turns out he didn't. So I guess I said that. If you have trouble with my weird sense of humor, raise your hand. Oh, let's go back to the slides again. So you may ask me how. That actually brings to the main philosophy behind the ML Legobricks, the recipes and ingredients. It sounds a little bit weird in the first place, and it takes me ages to find like a better like analogy for this concept. Just to help you better understand in this perspective, I'm gonna begin with my favorite spaghetti recipe, which is here. So everything is pretty much inspired and start by how to cook your spaghetti. I know this is dinner time, so bear with me for another 10 minutes. The left side is Sheldon's favorite spaghetti, and the right side is my favorite pasta. You see they have different recipes, and like essentially there are different ingredients, but it's not all the ingredients are different, right? You always need tomato, and it's not all the methods are different either. You always need to chop things down. You need olive oil all the time. You need like cream, you need cheese. So there are some common things between different recipes, not just a method, but also the ingredients. So that is how ML Legobricks work, essentially, because we treat different operations for the model as different small ingredients. And when we glue those ingredients together, we actually create different recipes. And this different recipe later on can be wrapped up and shipped as a Docker image on Sagemaker. And eventually, when you have so many different recipes, you can stack them over, or you can just like select a different thing, then create something very, very different. It can be a model, it can be, I couldn't think of a better example, but like think about you can have like tree engine based algorithm. Meanwhile, you have deep learning algorithm, all running parallelly, but all created from the same bucket of ingredients. I wish I explained that clearly about the real relationship between spaghetti and ML Legobricks. Again, if you have any question, please feel free to raise your hand. So that idea actually inspired us to think about, can we have a recipe for model building? Considering we have the same model building cycle all the time, and we are always apply the same sequence of operations on the data side. Let's quickly recap to the previous slides on, sorry, where is it? Wrong order. Oh, sorry, this is actually the next slides. The same model building cycle. Let's dive into details a little bit. We always come from the raw data, cleaning up. Then we have a basic statistical overview, which is EDA analysis. Then we have feature selection. That pretty much depends on your own methodology. Then we have feature engineering. This one is customized. This is totally option. No, it depends on you. ML Legobricks does not include this block, but it provides you options to plug this in or just plug it out from the whole model building cycle. Afterwards, we have pre-processing. Then we move to train, tune, and reporting. So this is pretty much the same model building cycle anytime and everywhere for all different machine learning models. Do I have any different opinion regarding to this? Then I will move to next slides. Here, like dive even into a little bit deeper to each building block in this whole building cycle. So we see the same operations applied to different blocks again, and again. For example, in the cleaning up pipeline in this block, you always need to check the data type for the inspection. You need to validate your data set is reliable for the further use for your model. And in EDA, you always need to check the missing rate of the feature, covariant shifting, moving average, anything which might be useful for model checking. Then to the next pipeline, you're actually like, sorry, this has been, let me quickly adjust my screen. So in the next step, for the pre-processing, you always do the pre-processing accordingly to different data type. For numerical, you need to replace the missing value, input scalar, typecasting. For ordinal, you probably have a frequency encoder, probably do not. This is optional, but I will provide you this opportunity to do that. And for high ordinal string, you pretty much do the one-hot encoder and other stuff. I'm not going to through every single operation, but I guess you get my point. For each different building blocks, like here, for each single building blocks, if you dive into there, you pretty much use the same operation all the time when you build a new model or rebuild an old model. So that comes to the question, why don't we automate everything? How come we cannot like have a recipe, including these ingredients and with a fixed order, but a reasonable order, and we have the recipe on hand, and when the time comes we need to build a model, we can quickly pull out this recipe, then building the model gonna be one click away. ML Legobricks exactly satisfy this purpose. Let's start with some pseudocode. So the concept from like recipes, right? Here in the actual coding perspective, each recipe is a combination of different pipelines. So pipeline is a real coding concept which we abstract from the same model building cycle here. So each block is pretty much each pipeline in ML Legobricks. So here's an example of clean EDA pipeline and feature engineering pipeline. The only thing we are asking is the model name and certain parameters. You may ask, if each model has certain different parameters, then how do you automate that and make sure everybody can use that as a black box? The answer is twofold. Firstly, every parameter will be given as a environment variable or exported from constant.py. And how do ML Legobricks customers know that? They will be offered opportunities to create or to refer these variables before they even create the model project by using cookiecutter. So this part is how cookiecutter comes to the picture. It helps you to be a little bit customized with your own target, your own variables, and some stuff like only related to your own project. Another fault of this question is ML Legobricks is not a black box. You can use that as a black box because if you don't have any special requirement, you can pretty much build a model by one click away with the existing recipes that we have provided. However, our ideal, like the final goal, is to help you to be familiar with this project and eventually be the owner of this project. We want you to go into this box and make contribution. Let's quickly check those pseudocode. I have 3 slides here, which starts from clean EDA pipeline. So you see in each pipeline, let's take the first pipeline as example. We are downloading data from the beginning. Then we're doing clean, then we're doing EDA. For each different method, if you actually go into the code, we have provided so many different methods for each pipelines to do different ingredients. And eventually you will have different recipes. And for feature engineering pipeline, again, this one is totally optional. You don't have to do that, but if you want, you can just pull out the standard feature engineering pipeline from ML Legobricks, which is a utility function transformer, which means you're doing nothing. You can smoothly going from cleaning EDA to the next step. Next one is pre-processing. This one is a little bit complicated because the pre-processing actually depends on the training algorithm you'll be used in the next step. But like in very general overview, we provide you different processing pipeline according to 3 different basic tree-based engine algorithms: CatBoost, XGBoost, and LightJBM. Eventually, like I said, we encourage people in Klarna to implement their own coding block in this ML Legobricks. So eventually you can have more different recipes, but this one is the standard recipe like I'm presenting here. And in the pre-processing pipeline, you can split your data set and start pre-processing. There are other different flags which help you to do a little bit more sophisticated work, but I'm just not showing them here. Now we come to train. So here, we haven't talked about Sagemaker yet because ML Legobricks allow you to train everything on Sagemaker. But if you don't have AWS account, that is fine. You can train everything on your local instance. That is allowed. What is important in train pipeline here is you have different methods. Again, train, calibrator, and you have different calibrator. We provide different algorithms. And you have performance, reporting, and feature importance. Any questions so far? Okay, I'll take that as a no. I do appreciate some questions because I want to quickly grab some water. But if there's no, yes, please.
Yeah, hi, Sai. I wanted to ask him then, but maybe if you want to drink water, I can ask now. Did you compare? So nowadays there is a lot of automation in this area. For example, Sagemaker recently released Sagemaker pipelines or ML pipelines there. Mm-hmm. Did you compare with this new offering from Sagemaker? I wonder if it gives you more advantages or disadvantages there.
Well, yes, more or less. Well, I guess essentially the difference between ML Legobricks and all other automated ML ops is, as far as I know, all the other ML ops is a black box. And for example, if you're using Sagemaker pipeline, you are pretty much using their own Docker image and their own training algorithm. Everything belongs to Sagemaker. You have very limited capacity to twist it, to change it, and to improve it. So eventually, I guess, for a fully automated black box pipeline, it's probably very useful for some companies who are not yet data science driven. But in other tech companies who are willing or who are ambitious to be more data science driven, I think it's good to have something like ML Legobricks. So you can have customized ingredients, which here customized functions. And most important function is, for example, your loss function when you train the model, right? If you're using other ML operations, it's very hard to achieve that. And as far as I know, like Databricks, SageMaker, pipelines, and ML flows, they're all kind of like very difficult to set up the right access and talking to different systems other than yourself. For example, if you're using SageMaker pipelines for all from end to end, it's very hard for you to plug in other services. That dependency is very difficult to tackle down. But if you're using ML Legobricks at a very low level too, everything is clear, then you can pretty much plug this whole part in on another service. You can wrap up everything as a Docker image, ship it. So I think that is a most like difference thing between ML Legobricks and other like a mature, real, market-wise product. Did I answer your question?
Yeah, thanks. Great answer. Yeah, I agree. Kind of SageMaker, obviously they want to lock you in their what they provide, right? And you cannot much deviate from what they provide. But yeah, cool. Thank you.
No worries. Any other question?
How does collaboration on projects through ML Legobricks work? Like currently in my current setup, we do use Metaflow by a bit. So therefore, are there options to really include ML Legobricks in this or in like a setup like that?
The Metaflow, if I used Metaflow about 1 year ago. I don't actually recall. So I think Metaflow is pretty much working very similar to ML Legobricks, right? I think the difference is the status. Like at each different step, Metaflow actually saves the status of the, not the model, but from the pipeline.
Yeah, exactly.
Yeah, right. So ML Legobricks has very similar concept, but we're not saving the status of the data. We are saving the data schema because the basic philosophy behind that is we're always applying operations on data side, which means at each pipeline you have in and out of data side, but that in and out can be simplified just by a schema of data, which is columns name and the data type of columns, because those two things are the only things has been changed during different operations. So instead of like saving the status, we are saving data schema by the end of each pipeline. For example, the clean EDA pipeline, after that, I'm gonna have a smaller data set because I'm dropping certain columns. So I will have a JSON file, including all the existed features after this pipeline and with the data type, because sometimes data type will be twisted during certain operations. You probably treat the Boolean as a numerical number somehow in some function. So at each step, if it's necessary, we generate and export a data schema, which also helps us to go back and forth. We don't have to, if there is anything wrong in the middle, we don't have to go back to clean EDA pipeline. We don't have to go back to the first function, download data. We can go to any step and start over from there, because we have data schema saved. We can reload the whole data set. You don't have to, but if you want, you can reload the data set and apply the data schema, got the smaller data set, then move on from there. Did I answer your question?
Yeah, absolutely. Thanks.
No worries. Okay, let's go to the next slides. Considering I only have 1 minute left. Wait. Okay, so now how does Sagemaker come to the picture? Again, please bear with my weird sense of humor. I just love this slogan, you know. Sorry, how do I go to? So shipping model recipe to Sagemaker, that is how Sagemaker comes to this picture. Every single pipeline can be shipped as a Docker image to ECR, then Sagemaker can take over from there. And how do I make that reliable and consistent and automated? Very simple. We can use with a great Sagemaker folder structure. Again, for people who's not very familiar with Sagemaker, there are so many things. This is very, very overwhelming. So I will cut everything, only tell you the most important thing. Think about that. If you're using Sagemaker, which pretty much means you are reading data, saving data, like everything regarding to data communication is in S3 bucket. And Sagemaker by default has a folder structure. This is not exactly the correct definition, because there's no data path, the actual path in either in S3 bucket or Sagemaker, but just let's bear with this wrong concept at the moment. So in Sagemaker, for different job, pre-processing, training, and tuning, you will be mounted default by different folder paths. And inevitably, you need to have the same mounted volume path on S3 bucket. As long as you agree with us, like the final path of the data in and out, for example, the data schema I have mentioned before and other stuff, then we're good to go. You don't need to do anything. This folder structure will be created when you create your model project by using cookiecutter. There is nothing you need to take care of except for your own AWS confidential. And that would be the environment variable you are given to cookiecutter in the first place. We are only asking you to agree with us. That will be the folder structure in your S3 bucket, and we will create that for you. Any questions? Then let's go to next slides. This actually has already been covered. What does cookiecutter actually do here? Well, I guess cookiecutter serves two purposes. And this is kind of like specific to Klarna, because eventually we need to deploy the model somewhere. And at the moment, we still want to have a full model structure, like full model project sitting somewhere for tracing back and forth, for monitoring, for better understanding. So in this case, Netherlands, we need to create a model project. Cookiecutter comes to a picture because this is very handy to use. And because ML Legobricks only asking for certain variables, it's very easy to create a template with cookiecutter. So you can just like read that as a predetermined feature before you even start building a model. But secondly, with cookiecutter, you're actually like gluing the code sharing library and Sagemaker together, because you're gonna have some scripts running model, like running a pipeline from end to end, right? So for example, if we go back to the pseudocode, this is only like 2 pipelines here. When you're actually running your model, since you have options to gluing them together by different orders or different ways, you still need to have a script somewhere. By using cookiecutter, we actually created a different template of scripts, gluing those pipelines differently with different pre-processing algorithm and different training algorithm. Those are kind of like a preset project. In this way, that actually allows people to have different options to cook their model. So that is how cookiecutter comes to the picture. Any questions? Here are like 2 examples of what does cookiecutter JSON file looks like and what does it actually do. So for example, here I'm asking certain things that were needed for this model because I'm actually training this model on Sagemaker, so I need my AWS credentials. And those are cookiecutter JSON file included, which means when I create my model project by using cookiecutter, the template that I have created, every time I will be asking, what is your system ID? What is your namespace tag? What is the profile? And those features, these parameters are different according to different team, right? You can set up that as a template for different team, or you can just like answer these questions every time you need to create a model project. After you answer this question, currently there will be a .in file created according to this cookiecutter.json, which pretty much just extracting all the parameters you have just been given, then set up like AWS configuration for you. That's it. It's only for convenience, but not just for convenience, because cookiecutter is also very, very powerful. This is only the tip of the iceberg. Questions?
Can you provide a little bit details? How does it run inside of Sagemaker? Is it like the whole pipeline is a single training job, or do you split it somehow by different steps?
Very good question. Very good question. It actually depends on you. You can wrap up different pipelines into one recipe, which means like after you wrap up with one recipe, you can ship it as one Docker image on Sagemaker. Then you can train everything from end to end in one Docker image on Sagemaker. However, you can also, because let's go back to the model building cycle a little bit. So raw data, clean, statistic overview, feature selection. Everything prior to feature selection is kind of like fixed, right? When you start creating the model. So even though you're trying different things on creating the model, like the 3 steps over there are pretty much fixed. So in this case, you can create a Docker image by only have clean EDA pipeline, ship that to Sagemaker, trigger Sagemaker job, get the result, save that somewhere. And in the following steps, you can always start from that point. And from that point, if you want, you can wrap everything from feature selection to report in one Docker image, ship to Sagemaker with training or hyperparameter tuning job. This is like all the options. If you don't want to, you can have different you can have different Docker image according to different blocks and ship them one by one on Sagemaker and trigger the job one by one, because you probably want to see like something differently in the middle. Did I answer your question?
Yeah, sounds great. And maybe one short question. You showed like internal folder structure of Sagemaker. Does it, like, what if, because it's a black box, what if this folder structure changes? Does it mean you have to figure this out again and propagate it to your cookie cutter template? Or
no, this one is fixed. This one, like if you're using ML Legobricks, which means you agree with us, your folder structure will be always look in this way. So you will always have, this is actually a little bit out of date, but you will always have your, for example, your raw data under temp folder, because all the folder paths were predefined in ML Legobricks pipeline. That's why we need you to agree with the Sagemaker folder structure. But if you don't want to follow the same structure, there's one way you can do to quickly change it, which is to have every single folder name as a constant and export it from constant.py, which is a file we use for reduce some manual work. But I would not recommend using that for the complexities, because this is just a folder structure. Like Sagemaker itself already have a default folder structure. For example, the opt ML, ML / preprocessing. I couldn't recall. So I think it's quite common and reasonable to ask our customers follow the same structure as we recommended.
Okay, sounds good. And just one comment about Sagemaker being a black box. We looked into hosting Sagemaker trained models in another platform. Mm-hmm. And when talking to Sagemaker teams, they actually said what they put in the Docker images is not secret, so they can provide it. I don't know if they provide it nowadays on public access, but you can actually ask them and they will provide like what dependencies they install there at least. So you can train in using Sagemaker training algorithm, and you can ship it somewhere else. But yeah, of course they prefer you to host models inside of Sagemaker.
Okay, I see. Okay, yeah, like sometimes AWS infrastructure is a little bit kind of like funny. I mean, they are grateful, like powerful. They are very, very strong tools, but sometimes the inner environment is kind of like still a little bit a black box to me. For example, when I use the Lambda function, I need to create, if I want to upload something new, I need to create a brand new virtual environment. And sometimes it does not work. You just have to use your own stuff. And that really ignores me sometimes. So I'm just like trying to use like I'm just trying to combine like all the good things together, but also have a little bit opportunities to customize stuff like in favor of our own requirement, not 100% rely on the third party service. So I guess that is like the deep down motivation of me to using this product, because I'm able to improve it, maintain that, and collaborating with other colleagues, we have a chance to make that better. But we are not saying no to other good stuff. We are just trying to collaborating with other good stuff, but not entirely like relying on them.
Sounds great, thank you.
All right, any other question?
I mean, in the meantime, if everyone is thinking about the question, I was wondering about, I mean, this tool now is internal in Klarna, right? So everyone could use it internally. Do you plan to make it public at some point? I mean, you shared with us a lot of things now, so I guess do that at some point.
Of course, I want to make that open source, but it's quite complicated. I'm not sure how it would go.
Okay.
Yeah. If we don't have any question, I want to show my last slides, which is the last, but also important. I want to give credits to my colleagues. I want to thank my colleagues, which are 4 engineers who actually initiated a product named ML Pipeline. That is actually the alpha version of ML Legobricks. The concept is not entirely the same, but they did a lot of research behind, and at the same time, ML Flow got created, so their projects got abandoned, but we do learn a lot from their ML pipelines. Those are 4 engineers in Klarna, and I got their LinkedIn profile. Yeah, but like, just feel free to contact them if you have any questions. And my teammate Anil, he's not here, I guess, but he implemented Vex library in ML Legobricks. The initial version, like I created, is only using pandas and NumPy for the data wrangler, right? But Anil implemented Vex, which is particularly good with huge volume of data, even on local instance. It's a very complicated implementation because you need to pretty much fix all the conflicts with NumPy and pandas. So great work, even though he's not here. And I want to thank to my manager. They are also not here, but I want to give them credits because they allow me to put efforts and spend time on ML Legobricks. Also helped me to refine my slides, just in case I leak any confidential information about Klarna. Well, that's it. Thanks for joining me, and thanks for having me here. Thanks, Chris, inviting me to give this presentation.
Thank you very much, Sai. It was really interesting, and also the questions afterwards were really nice. And I wanted, before going all, I'm just sharing now, we have a Slack channel for the PyData Cyprus community, in case you want to join and maybe have more of this kind of high quality and more technical but awesome discussions. Please join this Slack channel. And with that, if there are no more questions, thanks again, Sai, and hope to see you again in the future in some of the PyData Cyprus talks.
Thank you.
Okay, thank you very much. Good night.